Thanks very much, Carl. The talk today will be a little bit different from many of those that I give, in that it's more of personal reflections on what I think are the big challenges facing us as a species in the 21st century. And I'll spend about 3/4 of it talking more about what I think the solutions might be or the directions forward. The first quarter I'll talk about this idea of the Anthropocene for those of you who haven't come across it before. So there'll be 4 parts to it. Let's get right into it then with part 1, the Anthropocene. This is a term that was originally used by Paul Crutzen, who won the Nobel Prize for Chemistry in 1995 for his work on the ozone hole. And he uses it to describe how we as a species have gone from being hunter-gatherers, people who live very lightly on the land, to being people who now are a global geophysical force. So let me, in just a few slides, try to describe what we mean by the Anthropocene. And I'll start first not about the biophysical environment, but about humanity, about ourselves, and how we've changed. And here are just a few ways in which we've changed. The first one, and I think the most important one over the last 100 years or so, has been the spread of Western consumptive culture virtually everywhere. That's been what's driven the huge acceleration of human activities over the last, particularly the last 50 years, but over the last century. And if you travel to India, China, South America, Africa, and so on, it looks more and more like the Western world, and people are living more and more like we do. So this type of culture, which is based on high energy, high consumption, is spreading everywhere. Now, as a part of that, another trend that's occurring is the strong increase in the rate of urbanization. Now, why is this important? I believe it's really critical because it changes the human-environment relationship very fundamentally. If you look at people in urban areas, you could argue that they actually know more about the environment, and they do in a theoretical, in an academic sense. Most of you, most of my colleagues have studied biology, ecology, some sort of environmental studies, and we know about it in some way or another. But the people who lived on the land and still live on the land have a more practical understanding of the environment. Another way in which it's different is we start to lose our connection of what we draw from the environment in terms of services. For example, those who live in a city like that one there probably don't have any idea where their food really comes from and what it means to grow that food, what energy, what materials go into growing that food and transporting it, and likewise for other services that they draw. So over the last 30, 40, 50 years, we've fundamentally changed our relationship to the natural environment around us. Now, being a global geophysical force, we should be able to see our imprint on the Earth, and indeed we do. Our biggest imprint, in fact, is arguably not on the atmosphere, it's on the land, because we are terrestrial creatures and we've been modifying the land for a long, long time. But again, in the last century or two, the transformation has been enormous. It goes all the way from huge landscapes like this, which are basically industrial. The rivers are straightened, everything is planted in nice, neat rows and so on. It has really very little relationship to a natural ecosystem, all the way now to what many people call a new frontier, which is the genetic one. We're changing a lot of the terrestrial materials that we rely upon in very fundamental ways. We can see the imprint in other ways. We can see it in the diversity of the biology of the planet. And this is some work from the Millennium Ecosystem Assessment, which indicates that the species extinction rate has grown enormously the last couple centuries. It could be as much as 1,000 times the normal rate at which species go extinct. And if you look at the future, I find this a pretty frightening figure. 10 to 30% of mammal, bird, and amphibian species are currently threatened with extinction. That's in this century, by the end of this century. And that's due to a combination of factors, but the biggest factor has been our modification of landscapes, of the coast, and more recently our modification of the sea as well. We've also changed some of the big element cycles. A lot of people, of course, are very concerned about the carbon cycle and carbon dioxide in the atmosphere. I'll talk about that in just a moment. But in fact, we've changed the nitrogen cycle even more than we've changed the carbon cycle. And if you look again at a 100-year time slice, if you look at 1890, when there was very small human imprint on the nitrogen cycle, you see one very big factor. This is this figure of 100 units. Those are very big units of nitrogen, unreactive nitrogen, being fixed by biological systems so it can be used for plant growth and so on. And then there are other smaller flows of nitrogen in the system. But look 100 years later, look at this area here. This has actually diminished the natural flow of nitrogen from the atmosphere to the land because we've changed the landscapes, as I've showed you. But there's a huge new arrow here that didn't even exist 100 years ago. And that's direct human fixation of nitrogen from the atmosphere through industrial processes, driven, of course, by fossil fuel energy, which we didn't have until the late 1800s. What this is doing is putting an enormous amount of reactive nitrogen into the Earth system. And if you just look at the other arrows, you don't need to look at them in detail. You can just see the size of them changes quite significantly because something has to happen to this nitrogen. A very small fraction of it actually goes into our food. Most of it is lost to the atmosphere, to aquatic systems, and so on. And in my view, one of the big sleeping giants in this whole global change business is the accumulation of reactive nitrogen compounds in the environment, particularly on the land. We don't know what that's going to lead to, but it's certainly going to change ecosystems and is changing ecosystems in a very big way. And of course, people are worried about the climate. And just to remind you that the climate's always been variable. That's a 400,000-year ice core record. Many of you have seen this by now. But I want to point out here is the close link between carbon dioxide and methane and temperature, which is the red curve. We're sitting here in a fairly long warm period compared to the record in the past. But notice, of course, that there have been limits on how low CO2 goes or how high it goes during this natural variability. Now, this is what's really concerning the political sector and the media now, and that's the increase in carbon dioxide. That's the ice core record for a long period of time, 400,000 years. This red bar is the extra carbon dioxide that's gone in basically in a couple of centuries from human activities. About 80% of this line here is due to the burning of fossil fuels. So you can see that we've about doubled, or even slightly more than doubled. We're about 385 now, parts per million. We've a little bit more than doubled the natural operating range. And given the links to climate, that's why people are so concerned. If you look at the climate record, there's reason to be concerned. This red line here is the observed temperature increase over the last century. That's a record of natural variability going nearly 2,000 years back in the past. And you see that this is fundamentally different from any pattern of variability you see in the past. And so a lot of what you read in the media concerns this and how we get this under control. And one of the reasons for that is it's actually finally getting through to people outside of the research community that things are happening. And one of the big things that are happening is the ice on the planet is changing very rapidly. This is the breakup of the Larsen B ice shelf in 2002. That's along the Antarctic Peninsula. But now, in addition to the shelf ice, there's real concern about the ice that lies on the land. And there are three big ice sheets, Greenland, West Antarctica, and East Antarctica. And together they would account for about 65 meters of sea level rise, which is very large indeed. But now there's concern that we may be destabilizing two of those, Greenland and the West Antarctic ice sheets, and together they would give us something around 14 or 15 meters of sea level rise. So suddenly the penny's dropping, as we say in English, in terms of the political leaders of the world, that this is serious and it isn't something for the future, it's happening now. So this is a good example of the Anthropocene, that all of our millions of individual actions every day could actually cause something like a huge ice sheet to disintegrate. And that's starting to get through to people. So if I could summarize then the first part of what does the Earth system actually look like in the Anthropocene, here, if you like, are 5 big take-home messages. First of all, we're really homogenizing how we as humans operate. We're becoming more similar around the world in terms of our economic systems, in terms of our cultures, in terms of our languages. You know, I'm sort of embarrassed to say that I'm a native English speaker. I can go around the world and I don't even have to know any other language because more and more people are speaking English. Although maybe 20 years from now, Mandarin might be challenging English. But in many aspects, the human enterprise is homogenizing. But it's interesting, we still have diversity, but it's changing. We're losing diversity as groups of people, as societies. In a way, we're gaining diversity in what many call hyper-individualism, that there's more focus on individuals rather than on the society. So a lot of the diversity we see is people saying, hey, wait a minute, I'm different from you, and so on. And they're manifesting it that way. The other big trend, I think, is separation of humans from the rest of nature. This is a term that Bob Costanza uses, and I like to use it too. Not the separations of human from nature, but the separations of humans from the rest of nature. Because we are part of it, and we tend to forget that. And this is happening, as I mentioned, in terms of urbanization, but also in the huge growth of virtual worlds. Watch the young people of the world, and how often do you see them tapped into the computers, playing virtual games or experiencing virtual worlds? Very, very popular. But it separates people from the real world. In terms of the biophysical part of the planet, the homogenization and simplification of the biosphere, we're not only losing species, we're moving common species around the world so that the continents are looking more like one another in the biosphere as well as they are in the human part of the system. As I mentioned, the acidification of land, but also of ocean, because carbon dioxide dissolves in water, forms carbonic acid. This, plus rising temperatures, means that the world's coral reefs will probably be gone in the second half of this century. They'll be turned into another ecosystem. And there's more energy at the Earth's surface. This is the most fundamental way to talk about physical climate. We have more energy at the surface of the planet. So what happens? Well, it warms, ice melts, more intense storms, and so on. But it's all fundamentally related to one thing. We're just trapping and keeping more energy at the surface of the planet. Okay, part two. What do we do about this? Well, certainly in my country, which is a little bit outside the mainstream of probably what's going on in Europe and North America, but anyway, in Australia, people are realizing that climate change, and indeed biodiversity loss, salinization, other issues are important. But the focus now becomes on technological solutions. Can we find clever technologies that can change the way we use land, fix the climate, fix the acidity issues, and so on? But here's what I notice, particularly with the climate issue, is the technological solutions are often based on simplifying the issue. We simplify it down until it can be solved in one step by cause and effect logic. Here's how the chain of argument might go. Global change is often reduced to climate change. Global change is too difficult. Forget about the biodiversity loss. Forget about the ecosystem degradation. Forget about that. Let's just fix climate first, and then we'll deal with something else. And then climate change, which is actually very complex, becomes global warming. Temperature's getting too high. But other things are actually happening to climate. Global warming is caused by additional greenhouse gases. Well, that's largely true, but there are many other factors by which humans are changing the climate. And then greenhouse gases are simplified to carbon dioxide. Again, it's important. CO2 is a very important gas, and I don't want to diminish that importance, but nevertheless, it's simplifying a problem. And then we come down to, well, carbon dioxide comes from fossil fuel-based energy systems, so presto, we need a new energy system, often in the singular. And so there's the holy grail. We go out and we try to go from fossil fuel-based system to something new, depending on what your preference might be. And down in Australia and around in other parts of the world, there's a very vigorous debate. Basically, I could summarize it very simply. My energy system is better than yours. I have a lot of trouble in my university trying to get people to talk to each other. The nuclear scientists won't talk to the biological people. They won't talk to the solar people because they immediately start arguing with each other. And the reason is this. They all agree we need a much lower rate of CO2 emission. But they argue, I have the solution, and there's something wrong with your technology. So these are all pictures taken actually from the university in Canberra, where I work. We've got some experimental reactors. We've got two different types of solar people. We're trying to grow algae in ponds to draw down CO2. And we're working on biomass as a possible biofuel source, and so on. Now, there are obviously more sophisticated approaches to this. One that comes out of, I think it's Princeton University in the US, which uses this so-called wedge approach, which says, look, stop fighting, you guys, because there's no single solution. The problem is so big, we need a range of solutions. So we need to save. We need to not use energy. If we use it more efficiently. And then there's a whole range of sources, geothermal, reforesting to pull CO2 out. And you can read all those. All of which emit little or no CO2. So the idea is we do a little bit of this, a little bit of that, and by the time we add them all up, we make a big impact on reducing carbon dioxide. Now that looks pretty good. We may have solved the problem. But I just ask you to do a little experiment in your mind. So we may limit additional CO2 in the atmosphere, and we may slow and eventually reverse global warming. But let's go back from climate change to global change. what are the implications, say, for the provision of ecosystem services if we put all of those energy systems in? Well, just do a thought experiment. And let's actually say we find a magical energy solution. We're not thinking of it now, but some brilliant person in 10 years' time develops a new, clean, cheap, non-CO2 emitting and inexhaustible energy source. Well, the politicians would really be happy, wouldn't they? They could go back to doing what they've always done. We could grow, the economy could grow more, we could consume more, no problem with CO2, everything's fine. But what would this mean for the provision of ecosystem services on which we depend? I'll just give you one example, but you can run through the thought experiment. Here's a fairly well-known example. This is the collapse of the Newfoundland cod fishery in the North Atlantic, where the catches were going up slowly until about 1950 or 60. They went up enormously, and then they dropped. A little bit of recovery, and then they dropped again around 1990, and they haven't recovered, probably because the ecosystem is irreversibly switched to another state. Now, the question is this. If we had a renewable or other non-CO2 emitting energy source, would that have prevented the collapse of that fishery? The answer is unequivocally no, because the people who were thinking, or I should say not thinking, about what they were doing there didn't care about the energy source. At that time, it was certainly cheap. Petroleum-based systems were very cheap in the 1950s. So it didn't matter for them. That was a small factor in what they were doing. Had that been a solar-based or a biofuel-based or a nuclear-based, it would have made no difference whatsoever. The difference was their understanding or lack of understanding of the biological system in which they based their industry and all sorts of institutions which didn't allow them, even if they did have the understanding, to implement different fishing regimes. They had very little or nothing to do with the energy system. So what I'm arguing here is beware of the technology-first solution. It's a very comfortable solution because it doesn't actually force us to think very differently about the planet and how we operate with it. It's just reduced down to, we have a bad technology, all right, we admit fossil fuels aren't so good, let's just put another one in and continue on our way. So I would argue that we have to be careful of that. So part 3, something we call the sustainability gap, and here I'll report on some work we did at my school at the Australian National University over the last year. And that is that something deeper is going on here, and we need to consider that. This is one attempt by the Global Footprints Network to try to estimate in a crude way how much of the Earth we're actually using to sustain the human enterprise. Now what they're doing is a very crude attempt at saying, all right, where do we get our ecosystem services? How much land and ocean does it take for each human in various countries to get your food and so on? And how much land and ocean does it take to absorb the effluent, to absorb the carbon dioxide and so on? So you can add that up for 6.4 billion people, and they measure it in terms of the number of Earths, because we can measure how much land and how much ocean there is. Now there are debates about how good this methodology is. But nevertheless, I think people would agree, certainly agrees with the Millennium Ecosystem Assessment, that over the last 50 years, we have really transformed and used beyond sustainable levels many of the world's ecosystem services. By this estimate, we've gone from using about half of a planet Earth past the one planet Earth somewhere in the 1980s, now we're up about 1.2. And all this simply says is that we're in so-called overshoot, that we're using up the natural capital of the planet faster than it can be regenerated. And that's the bottom line. But there are many other analyses, I think, which would agree with that. So there is something going on. And it doesn't matter if you change the energy source. This is driven, obviously, by fossil fuel energy systems. But if you change to clean, green energy, would you change the shape of that curve? I would argue no. Just by changing the energy system, you wouldn't change that necessarily. We must do something else. Well, here's a good example. This is a graph that I actually use when I give briefings to the government in Canberra. I work part-time as a science advisor to the Australian government, and it's very interesting to watch their reaction. This is my take, my estimate on what will happen if we go up this temperature curve of the IPCC projections. Interestingly, the 2007 IPCC report actually didn't change this. If anything, that tail got a little bit higher up at the top. The first thing I point out to them is we're going to go to 1.5 degrees no matter what. That's committed. It's in the pipeline, so to speak. And it will be very difficult to keep the temperature increase below 2 toward the end of this century. And I started to say, what happens if you hit 2? Well, you're going to get very large biodiversity loss, you'll lose coral reefs, for example. Now, by the time we get to 3, now the median of the IPCC projections is something in here. We'll probably lose most or all of the Greenland ice sheet at 3 degrees. There's a question of how long that's going to take. And the latest information may be it may be quicker than we thought about 5 years ago, given the instability of the land-based ice there. And you can go up this. And my argument here is I don't think we could tolerate 5-degree temperature change in a century, given everything else that means in terms of the other physical changes to the planet, changes to the ecology of the planet, and so on. And I tell my political masters there that if you think you can simply let the thing go and adapt, you better think again, because by the time we go up toward that, we won't have a modern civilization that's capable of adapting to anything. That it's a pretty serious thing. So you can go through these arguments and you would say, well, that should have an impact on people. That should change things. But these arguments have been around for about 20 years now. Now, the interesting thing is in 20 years, we can actually see how humanity has responded to this. Well, here's how we've responded. These are the various curves that it would take to start turning that big climate curve around. These are the various stabilization scenarios. Roughly, this corresponds to about 2 degrees, this to 3, this to somewhere up around 4 or 5. So these are the various curves. This red one is what I call the horror story. That's the business as usual. We don't do anything. We just keep burning fossil fuels. The black line is the observed rate of increase. Now, if you blow up this little area here so you can see it in more detail, it looks like that. We're actually right on the red curve. We're already above the 3 stabilization curves. So remember that this information has been around now for about 20 years. These stabilization curves came out in the early 1990s. So we've had a lot of time to reflect on that. We've had some time to respond to it. And yet our response is we haven't done anything. It's actually got worse. But the climate one's probably the most dramatic, but I could give you many other indicators of ecosystem services globally, of other sort of so-called sustainability indicators, and we've gone backwards. Now, we asked this question to my school in Canberra, to the academics there, and said, look, it's been 20 years this year since the Brundtland report came out on sustainable development. Sustainable development is written into 150 pieces of legislation in Australia and probably many in your country and all sorts of other countries. It's been widely accepted as a high-level social goal, like democracy. And yet we go backwards. So the first question, why is this so? What's missing in all this? So here's some things we looked at. In fact, one of my colleagues said, really fundamentally, it's the way we actually generate knowledge is part of the problem, using the Western scientific method. Because that leads to a resulting approach in management and policy that is almost inescapable from the way we generate knowledge. Well, how do we do it? We separate knowledge into disciplines, building silos and losing connections. I mean, I was very fortunate to spend many years here in Stockholm working with IGBP, which is highly interdisciplinary. I went back to a university. I was absolutely shocked at how often this word was used, discipline, and how the university was organized around it, and how if anyone challenged that, they looked at you like, what planet did you come from? And I kept telling him, I think that's part of the problem. No matter how good you are in your discipline, that's part of the problem. Well, this, I think, we're prone then to look for simple cause-effect relationships. That's how modern Western science works. We take pieces out of the system and we study them individually. We write many papers about them. We might even win prizes for doing so. But we lose the properties of the system as a whole. And we never put the pieces back in. We leave knowledge generation and problem solving to so-called experts, separating them from the everyday lives of the population. And I'll get onto that in a moment in terms of management. But above all, we tend to take a deterministic view of the world. Look at the response of IPCC and the climate research community to the latest assessment. We need to reduce uncertainties and we need to model the future. We've been doing that for 20 years and we haven't reduced uncertainties and we're still not able to model the future. So what are we doing? Have we gone off on a wrong path? Well, this is the way we do it. This is actually some of the work in IGBP. I was a bit frustrated there too, in that we tend to look at this very complicated Earth system at very many scales from the planet right through to basic physics, basic chemistry. But we split it up. We got people looking at the land, ocean, atmosphere, the ice, the soil, and so on. But we're really frustrated, and we have much less effort spent studying the interactions between them or the Earth system as a whole. We certainly tried, but it was hard to find the communities out there that were doing that or wanted to do that. They're actually very small. So as I mentioned, what did we do? We tried to model a biophysical Earth system. We've been saying for a decade we need to put humans interactively in this system. Nobody actually really does it yet, not at the Earth system level. The usual approach is to do this and to project the future and inform the policy. Policy people say, well, can you tell me a little bit better how much temperature change we're going to expect? That's the common question. And the way we do our modeling is, well, we've got to put some more stuff in here. You know, we've got to put more aerosols in. We've got to put dynamic vegetation in, and so on, and incrementally build it up. But 20 years down the track, and I don't think we've made much progress. We certainly know what the problem is, but we haven't made much progress in dealing with it. So what are the implications of management for this Western scientific approach to generating knowledge? It's the rise of what some people have called scientific management, which relies on science as the foundation for efficient policies, oftentimes via central authority. And it works in sometimes. For example, the acid rain problem in Northern Europe, northwestern US, was generally solved by this approach. But to do it, you need a bureaucratic structure with the appropriate mandate, jurisdiction, expert personnel in it. The experts provide the scientific knowledge on which top-down decisions are made on policy. You can see a lot of Australian environmental policy is made this way now, for example. But in a complex world, there are many cross-scale interactions, which this system doesn't handle very well at all. And it tends to drive the scientific management approach into policy gridlock. Now, for those of you who work at the Stockholm Resilience Center, you know all this, because that's part of the problem that you're dealing with. But when you go out in the world of politics, in many parts of the world, they still operate on this type of approach. So back at our school, the Fenner School at the Australian National University, we put two young scholars and basically to lead the whole school to say, what's going on here? Why are we having this sustainability gap? 20 years after Brundtland, and we're going backwards. So this little diagram tries to summarize what we came up with. You can look at the degree of unsustainability or perhaps the risk of collapse of any parameter you want. This could be carbon dioxide in the atmosphere. It could be the rate of nitrogen flowing through the coastal zone. It could be anything you wanted to look at. And you have some target. We want to limit CO2 to 450. Or we want to limit the amount of nitrogen coming through to a certain amount. And you look at what's going now. The trend is, oops, we're already past the target. How do we bring it back down? Well, we must have some policy. For example, the Kyoto Protocol. Short-term action, 5 years, and it tends to be very pragmatic because they had to get it through. What does it do? It tends to just nudge the overall line a little bit, but the trajectory just keeps on going. It's exactly what's happened with the Kyoto Protocol. We're still, as I showed you on that other curve, shooting right up here. What we need is to actually bend the whole curve and start bringing it back down. And we're not even close to that on the climate issue. So what's missing? Well, we've reckoned that what's missing are what we called long-term and foundational issues. Now, one of the strengths of our school, which I was very lucky to inherit when I took over as director a couple of years ago, is that we not only have natural scientists and social scientists and economists, we also have humanities scholars. And it was these people who challenged the rest of us and said, it's not good enough to get natural science and social science together. You still won't solve the problem. And that's been a mantra for a long time. And it's not good enough just to get ecological economics in there as well. You've got to get the humanities in there because that really hits what we call the foundational issues. This is why we're not making any progress on these sustainability issues. This is why technology is not going to solve the problem as well. So let's look then at the last part of my talk about what are these foundational issues and how might we deal with them. The first one I think is exemplified by this cover of Newsweek magazine of a few years ago now, looking at some battles over the World Trade Organization. But the foundational issue here really is encapsulated here, whose world, or more accurately, whose perception of the world should be dominant. One of the big problems we face is that we have no common view, perception of our place in the natural world as a species. Now notice this one. This also tells you something very interesting. Here you can see these people. They've come straight from the boardroom from some big multinational company. You can see these people. They're obviously from a Western country, probably the U.S., who say, no, wait a minute, you guys are going down the wrong path. But where are the 80% of the world who don't live in the West? They're not represented in that image. Okay? And they have another perception, or perceptions, of the world. Now, a colleague of mine, Bert de Vries from the Netherlands, tried to capture this. He took headlines from the newspapers and the media over the last couple of years, which he thought indicated different people's perceptions of the world. Now, he mapped them onto the various IPCC scenarios, which you can see there. But the interesting thing is, look at how different the perceptions of the world are. Here are the A1 people. These people are the free market economists who think everything's fine. Maybe technology will solve the world. You know, just go out and do it. New global age, hyper-individualism, and so on. You can see the common future people, shared responsibilities, ecologically driven, and so on. And here are the people who are worried about security, fortress world, barbarization. The biggest thing is to enhance security in the Western world, turbulent neighborhoods, and so on. And you can see that there are all sorts of different perspectives on the world and on humans' place in the world. There is absolutely no consensus at all. Now, I had to give a talk a few years ago at the Vatican, so I thought I would deal with this fundamental issue, this foundational issue of our relationship with the environment. Now, this is obviously a theme that's been around for a long time, and since I was talking at the Vatican, I thought it might be useful to look at religion, because religion actually has a lot to say about that. So here are what some religions say about the interaction of humans and the environment. The interesting thing is, I found there's probably more consensus across various religions and the role of humans in the environment than there is now in contemporary Western society. Well, there's the Christian religion. Hurt not the earth, neither the sea nor the trees. And that's a theme that comes through quite a bit. Although there are mandates in the Bible that humankind should have dominion over the earth, there are many, many cautions that it should do so wisely with the role of stewardship of the earth. This is from the Holy Koran. And if you look at this, Allah, who reveals himself in man's intelligence and in the nature around man, balance and justice, goodness and care. Words like balance and care are in the laws of the Islamic world. And if you look at the Buddhist religion, they say it rather poetically, without the willow, how to know the beauty of the wind. The one I really like comes from my own country, and that's the Australian Aborigines. And that, to my way of thinking, is an incredibly sophisticated perspective on biogeochemistry. We're only here for a short amount of time to do what we've been put here to do, which is to look after the country. Very different from contemporary Western view of the role of humans. We're only a tool in the cycle of things. We go out into the world and keep the balance of nature. It's a big cycle of living with the land and then eventually going back to it. Notice the use of the concept of cycles. They were very attuned to cycles, and they're also very attuned to living in an extremely variable and erratic environment. But their perspective of their place in the world is vastly different from our perspective of our place in the world. So what are the core values of our society? If you look at those religious values, which had a lot of things about balance, care, stewardship, cycling, and so on, no matter which religion you came from. Well, what are our core values? Well, we certainly are going toward a single world economy based largely on capitalist neoliberal economic principles. We live under a growth imperative. If you look at any political party around the Western world, we have an election campaign on now in Australia. Each party is trying to say they will deliver better growth. Thus, vote for us. That means usually increasing consumption per capita based on increasing individual wealth and rising consumption expectations. This is now happening in the developing world, of course, too. There's an increasing commoditization of public goods. More of the public sector is being brought into the private economy. And there's a decentralization and privatization in general of environmental management. So those core values are very different from those of our ancestors in the past. One of my colleagues in Australia, Ian Lowe, has come up with what he calls the sustainability hierarchy. And it challenged this idea of a triple bottom line. Now, many of you have probably heard of a triple bottom line, which means we need to balance somehow economic, social, and environmental perspectives or aspects of societal development. And this is how you get sustainability. He says rather it's a hierarchy. And if you change the word environment to life support system, it casts a slightly different meaning on what he's talking about. Because it's quite clear that if you don't have a well-functioning life support system, you're going to be in trouble. Because you have to spend more and more of your resources to fix or maintain your life support system rather than going on and doing other things. But then the next in this nested hierarchy is not the economy, it's the social system. You have to have a well-functioning social system. And then if you have those two, you can certainly develop a thriving economy. What's happened in modern times is we focused a lot on this. We've tended to take those for granted, and we can't anymore. There's a good contemporary example of this circle here, social systems, and that's the collapse of the Soviet Union. When the Soviet Union collapsed and they did not have a well-functioning social system, there was no way they could have a well-functioning economy. It was actually quite amazing that some of the simplistic notions that came forward in the early 1990s, well, now that communism is gone, we just put in a free market capitalist system, and within a few years, and I remember seeing projections within a few years, they'll be humming along like everyone else. But they forgot that the social system was in disarray, and it took a lot longer to get that back in order. And even now, you can argue that they have a fairly distorted economic system because they still have problems with the social system. So you can see examples of this. Well, I sort of said the way we generate knowledge is the real problem. Well, how do we do it differently? Well, again, I think I'm preaching to the converted for those of you who come from the Stockholm Resilience Center, because work like you've done have pioneered a lot of this, but it needs to get out much more broadly. It needs to get out in universities. It needs to get out into the general public. Well, here are 4 things I think are important. One is participatory research involving stakeholders, user groups in the design, implementation, and communication of research. Some people call it the cogeneration of knowledge. Now, this seems obvious that if we're going to move towards sustainability, we've got to do this. But I'm just amazed at the anger that this generates in my university, that I dare suggest that some of these academics actually talk to real people out there. It's just amazing how set we are in the old way of doing things. As I mentioned, we need systems approaches focused on the system as a whole, with things like emergent properties, nonlinearities, thresholds, all these things that systems do, but pieces of systems, when taken out, don't do. This is important, often forgotten. We need what I call scale fluidity. We need to move from local to global and back again, depending on the nature of the question, because there's all sorts of scale linkages. And this last one is the one I'll finish on in a few minutes, transdisciplinary team-based research, bringing together a wide range of disciplines to tackle complex problems in depth. Now, the key thing here is that the research is driven by that. It's driven by the problem. It's not driven by the discipline. The teams are only assembled after you've defined the problem, or as you define the problem. What's some of the new type of knowledge generation we need? Well, at the global scale, here's an example that was generated by John Schellenhuber of the Potsdam Institute. This is a very different way of looking at the Earth than the usual, let's do a little bit better climate model by adding the next aerosol into the module. It's saying, standing back and saying, what are we really worried about how our life support system operates? We're worried about some of these surprising changes which may really affect us. An example being, well, I've talked about this, the West Antarctic and Greenland ice sheets. Here's the deep water formation that's associated with the Gulf Stream, perhaps the collapse of the Amazon forest. This one is really worrying Australia quite strongly. When ENSO is triggered in a strong positive ENSO phase, we have really severe droughts down the East Coast. It looks like it's heading almost toward a lock-in phase of ENSO as the Pacific Ocean warms up. So, I mean, this has huge implications for this part of the world. Indian monsoon transformation, well, about 2 billion people depend on that monsoon system in one way or another. So this is a very different way of looking at it, saying, let's just not incrementally go to see if we can do better than 5.5, can we get to 5.7 degrees? It's saying, what are some of the real abrupt changes, some of the trigger points that we need to understand better? That's a different way of looking at it. Another colleague of John's at Potsdam is looking now at regional scale problems using systems approaches, using biophysical systems, social systems, putting together and coming up what he calls syndromes. One they've done a lot of work on is the Sahel syndrome, where it's not just looking at cause-effect. Is it humans using the land too much that causes degradation? Well, no, it's a whole syndrome that involves institutions, climate variability, and so on. And you have to put all these together to understand the system. So these are new ways of generating knowledge. This is one that's very familiar to people here. and that's to use resilience thinking to sustaining social ecological systems. Again, it's a very different way from this sort of science-based top-down management approach. And enormous amount of work, I would say, over the past decade, much of it being led by people here in Stockholm, which is starting to change the way people think about how we manage these systems. In terms of the future, I'm becoming more and more disinclined to look at the big climate models, the big other models, because there's so many uncertainties, many of them on the human side, that we'll never get around. A very different way of doing it, and I think a more robust way, is to use scenarios. Because what scenarios do, it allows you to put a consistent, internally consistent picture of the future together. It could be a future that you don't like, it could be a future that you want to have, and so it could guide people as to how they go into the future. Now, the interesting thing is, when you look at these various storylines, these are 4 of them from the Millennium Ecosystem Assessment, but in fact, there are about 35 or 40 different global scenarios floating around from various groups. Different people actually react to them in different ways. Now, I'm amazed when I talk about scenarios to people, because I would naturally like, well, I certainly don't like this one, this fragmented world. Some people actually think it's all right, some people I've talked to. They don't care about the rest of the world. But something like the adapting mosaic, which I find a quite interesting one and maybe a positive way forward, other people don't like. They would much prefer the techno-garden or some combination of the techno-garden and something else. It just goes to show that people actually have very different worldviews still. But scenarios are good at bringing them out because you can understand why people like certain things and not others. Now, how powerful are scenarios? Well, the good example of that is the one from South Africa. Many of you may have known about this. If you don't, very briefly, during the apartheid regime, a group of South African leaders got together and said, look, some changes are going to happen, whether we like it or not. This system can't go on forever. What's going to happen? And they sat down and had a number of scenarios. And each one of them was so horrible they didn't want to contemplate it. The only one which actually had a future was to share power and basically get rid of the apartheid regime and have a much more even democracy, including all different groups of people in South Africa. Now, during the height of the apartheid regime, that was thought to be impossible. People said, you can't do that. It just won't happen. But by using a scenario approach and looking at all the alternatives and said, we just don't want to go there, people came around to say, well, we really ought to think about this. And in fact, they did it, which is quite an amazing transformation, and they did it peacefully. This is the sort of thing we have to look at when we look at these huge, almost intractable global problems. Which are the different pathways we can go forward? And we've got to do it bringing in people who don't agree with us. We have to bring in people from the corporate sector, people who think technology is going to solve the problems. We have to walk through internally consistent scenarios to really understand what the implications are. I think this is a far better way forward than generating a whole lot more models of what might happen. Although, of course, they inform the scenarios. Okay, conclusions, and then we'll have some discussion. Well, if you ask me to put 3 major points of all this sort of rambling talk together, I would say these are the 3 things that I think are our big challenges for the 21st century. Number 1 is absolutely critical. We need a common worldview, at least so far as the fundamental relationship between us and the rest of nature is concerned. We can have different cultures, we can have different political systems, we can have different economic systems and so on. But I don't think we can go very much further without having a common worldview at a very fundamental level of us and the rest of nature at the global scale. If we don't have that, we'll never come to agreement on post-Kyoto, we'll never come to agreement on biodiversity or anything like that. We've got to have that, and that's not going to be easy to achieve. Second, I think we need to transform the way we generate and use knowledge. That's a huge, huge challenge to the university sector, which after all are medieval institutions and really in a way very much stuck in their way. We need more places like the Stockholm Resilience Center. We need more places like what we're trying to create with our school, more places like the Potsdam Institute and so on, who actually think and do new approaches to generating knowledge. And I mentioned this, I didn't talk much about this, but we need to learn from the past. Humans have faced all sorts of challenges in the past, and some have succeeded and some have failed. We need to do a better job of understanding why. What confers resilience or even transformability on some societies, and what makes some societies very rigid and prone to not being able to cope. I'll just close with A couple images. This goes back to the Enlightenment, where we actually had interdisciplinary, transdisciplinary human beings, had expertise in arts, letters, history, languages, math, science. It's all embodied in one person, the so-called Renaissance man. Now, I Googled Renaissance man to see if I could find if there are any Renaissance women. And the answer was no, there aren't if you go into Google. I suspect there were Renaissance women, but they didn't get the notoriety and credit that Renaissance men did. So anyway, I think we need Renaissance people at the moment. But now there's a real trick here, is that the amount of knowledge around was many orders of magnitude less at the time that Leonardo da Vinci lived than now. I think it's impossible for one human brain to be able to encompass the depth of knowledge we actually need in many of these areas to tackle the complex problems that we do. So one of the things we're trying at the Australian National University is not to have Renaissance men, but to have Renaissance teams. And this is a Renaissance team we've put together that's looking at water issues, which are some of the biggest issues we face in Australia. And these colleagues come from natural sciences, social sciences, law, economics, humanities. This chap up there with the umbrella is an artist, and he uses visual art to get Australians to think about their relationship to the hydrological cycle. It's a very interesting group, and I think we're doing some innovative things. So with that, I will leave it, and hopefully we have some time for discussion. So any questions or people who want to violently disagree with me? Yes.
I agree with everything you say, but maybe two minor points that I would like to have your comments on. One is probably a trivial one. You are very critical about technological solutions, but the way you are critical is that if technology would solve our energy problem, it wouldn't solve the sustainability issue. In that sense, I fully agree. On the other hand, maybe you could reflect a little bit on what we can expect from technological solutions or not.
Yeah.
And the second issue, if I may, then is you said explicitly that the real problem is the way that we gather knowledge, so in the disciplinary silos, as you mentioned it. Well, I do not disagree that there's much to gain from other ways of creating knowledge. On the other hand, I don't think it's the main problem, because you said very clearly that we do have sufficient knowledge to know that we're not on a sustainable track. And regardless of that, we don't seem to move. So there seems to be, the real problem seems to be somewhere else, not really in creating knowledge, but how to handle knowledge in societal development or not.
Okay.
Could you reflect on those 2 points, please?
Yeah, the technology one. Yeah, I'll give a fairly simple example there. I agree with you that technology can be part of the solution. The point I was making is that technology on its own, with people assuming we have the same value system, the same institutions and so on, isn't going to solve the problem. For the reasons I gave, is that if you do that thought experiment, I don't think we would in any way improve our use of ecosystem services or conserving and maintaining ecosystem services, no matter what energy system we had. But if we tackle the foundational issues and get to the core of what I think the problem is, technology can be a big ally if it's implied in a framework of a different perspective of how we live with nature. So I hope I didn't imply that we're going to go back to not using any technology. I think we have to be very, very wise about which technologies, how they're deployed, what institutions are developed to guide and manage those technologies and so on. So it's far more complex than the magic bullet. And the reason I sort of reacted strongly to the technology thing is certainly I think in the English-speaking world, there's an assumption of, all right, the climate change issue is really important, we need a new technology, and they're not tackling the foundational issues. So I think technology can be a crutch for not having to deal with something deeper. Now your second question was the knowledge question. Well, I think one of the foundational issues that I was raising is the fact that we tend to compartmentalize knowledge. Again, some of that knowledge can be very valuable, but not on its own. So the trick is to get a more holistic view to a lot of these problems. And I see that, again, all the time interacting with people from other parts of my university who conceive of the problem only from their discipline. And we have an old English saying that if your only tool is a hammer, all of the world's problems look like nails. And so that's exactly what you find with people who come in from one discipline. So I still stick by that. I think the disciplinary approach on its own leads to more problems than it solves.
But if I may, I do not disagree on that point. But on the other hand, you strongly argue that there's sufficient knowledge to know you're on the wrong track, and still nothing's happened. This was the figure that...
Yeah.
So I just argue that the main problem is somewhere else. Even if you generate more knowledge in the way that you suggest, we are solve the problem. That was my main point.
Yeah, no, and I don't just disagree with you on that. I was also hinting that some of the...
interaction of knowledge in societal development, much more than pure knowledge as such.
Yeah.
Programs.
Okay. Right. Other questions? Yes?
Are you yourself a pessimist or an optimist? Do you believe that we will win?
Well, I guess I've got my glass isn't half full, so I guess I should make it half full. So, with apologies to Carl Euron, I will tell this little story that the optimist says that the glass is half full, and the pessimist says the glass is half empty, and the economist says the glass is twice as big as it needs to be. No, I tend to be an optimist. I think if we look at examples like the South African example, I recall when our rugby team back in the 1980s and our cricket team from Australia were banned from going to South Africa because of the apartheid regime there. Of course, which is a big blow to us because we like to beat them in rugby and cricket every chance we get. But that really highlighted the issue of this intractable regime, and there was a lot of debate about, well, should you have sport boycotts? Does it do any good? Is it counterproductive? Will this ever change? And there was a lot of pessimism about the future of Southern Africa. But you see, people make choices. Look at Zimbabwe, look at South Africa. They're very, very different. The future hasn't happened yet, and we do have choices. So basically, I tend to be an optimist because I see a lot of positive things happening. One of the most positive things I see happening is interacting with people outside of my area of endeavor, basically research, teaching, education, and interacting with corporate leaders in Australia, for example, and actually seeing them thinking about these issues much more than I have in the past, and that gives me a lot of encouragement. Interestingly, a lot of them say that they're doing that because of their children. Their children are pushing them and saying, look, you know, you're stuffing up the world for us, you got to change. And some of them, a lot of them are actually getting the message. They're running ahead of governments, in my view. So I think there's some cause for optimism. The next 10 years is crucial. If we don't see a big transformation in the next 10 years, then I think we're in real trouble. But there are signs out there. Does that answer your question? So basically, I'm an optimist, a guarded one, but an optimist. Yes?
Thank you for a very inspiring talk. I was wondering if you could elaborate a bit on number one of your conclusions, which is the very large issue of evolving a common worldview. Because I suppose that you were talking about evolving a common worldview regarding the relationship between humans and the rest of the nature would involve different modes of knowledge, spiritual, scientific, cultural, all
yes.
You know, how, I mean, you have to, you know, compartments there too. Have you done any practical workshops? Have you, what would the meeting grounds between such different modes of knowledge look like? Do you have any ideas or experiences there?
Not many. I think the people who are challenging us a lot from the research community are people from the creative arts. So we're just starting some projects in Canberra that involve artists, musicians, and so on. And I've been quite amazed what they do. To give you an example, we had a 2-day workshop at our university on some of the water issues that face Australia, which are huge. One of which are salinity, salt coming up in the landscape. So we asked various people from the university to come from their disciplines, their perspectives, and give talks. And so we had some really fantastic presentations. We had some social scientists talking about governance in our big river basin and how it's not working properly. We had scientists talking about what you might need to do. Then we asked this guy with the umbrella, the artist, and what he did for his presentation was he walked in with a painting an artist's interpretation of a saline landscape, big painting, just put it up there. He had 20 minutes like everybody else. And then he had 3 musicians come in, and he said, spontaneously compose something in reaction to that visual image. And it was quite spectacular in its effect of a completely different perspective on a saline landscape. Not intellectual, but how people felt about it. So when you're dealing with the general public, people react to issues not just in intellectual ways. They react with issues in all sorts of different ways. And so one of the things we're learning is that by combining these, you actually can have a much more powerful message. It's not that you leave out the understanding that researchers have got, but when you combine it with how people from other human endeavors are reacting to this, you get quite a powerful experience out of it. So that's one of the things we're trying to do, is to involve the people from the artistic side of things on a lot of these environmental issues. Now I notice at the conference here in April next year, the Resilience Conference, there's going to be something similar going on, which I think is really an interesting way to approach it. But you see now some of the world's religions are getting involved in a lot of the environmental issues and bringing those perspectives in. So look, I think it's going to be a fairly pluralistic, noisy place for a while, but I think that's probably good. That means that things are happening. There's no easy, neat way that you integrate this, but I think that's part of the way we are as organisms. Yeah.
Being a psychologist working within the sustainability area, I really appreciate this. And I think that there's one, and also maybe continuing on what you were saying there, I have, of course, and you couldn't fit in everything, and I think you're working with the individual as well. And we need to know how people are working and the resistance. A lot of these things are being, what's happening within us. And also, are you familiar with Manfred Max Neff and
Yes.
his fundamental human needs? And I think that is another part that should be involved in this.
No, I agree.
I don't think you disagree.
No, absolutely not. I agree.
No.
That's a good point, indeed. There was a question? Yeah.
Yeah, I was working in the renewable energy system, so I'm really getting stuck in somewhere just trying to think, just how you, because this is a complicated system, as your point, that you need maybe more longer term perspective and a holistic perspective as well. So thinking is that, what's your view on how solve the problem? Well, there are 2 ways. One is to solve the problem that we are having right now, and which is really complicated, that probably none of us have come to a sound solution. And secondly, we're trying to prevent problem that's going to happen in the future. That's if we don't, take the preventive approach. So there should be a balance of both. So what's your view on that, and how we because we're not trying to avoid and solving a problem by creating another one. This is just a precise point your talk.
Yeah, the issue of preventing something really bad from happening is an interesting one. John Schellenhuber from Potsdam and his colleagues have developed something called the guardrails approach, which means there are certain guardrails in various aspects of the Earth system that you don't want to go past, and you need to do everything you can to avoid those, perhaps even if you exacerbate other problems for the time being. The worst case example of that, which is enormously controversial, I didn't bring it up, is this idea of geoengineering, that if everything else fails, if we simply can't get on top of this, maybe we have to resort to some geoengineering attempts to keep the Earth within these guardrails. For example, one proposal was to put aerosols up in the stratosphere, sulfate aerosols, which scatter incoming radiation so they would cool the surface. Now you could, in principle, bring the surface temperature back down by doing that. But of course that wouldn't solve the CO2 problem in the ocean acidity, because that would still be churning away. Also, you would probably drop food production because obviously terrestrial plants need incoming solar radiation, and so on and so on. So it's a hugely interesting, hugely controversial issue. But this issue of guardrails, of limits, and should we just make sure we avoid those and then deal with the other problems is what some people are saying. Whereas others, for example, I showed you a picture of the various energy sources. If you look at biofuels in Australia, it's a very controversial topic. But the best arguments are those that are based on wood systems rather than on crops. And they do several things. They start to reverse the salinity. They give biodiversity outcomes. They keep rural Australia, the societies, more viable because they provide a very distributed income stream and so on. So the proponents say this is much more than simply an energy solution. It's tackling 3 or 4 major issues for the Australian landscape in a synergistic way. So that sort of thinking is interesting because it's saying, yeah, we've got to get on top of this big problem, but if we're really clever, we can do it in synergy with solutions to other problems rather than looking at it in a blinkered way. So that's the sort of debates I think we need to start having, is to look at them, look at these possible energy systems in a far more holistic way. Yeah.
This is how you, because it's climate change, and this is a totally local, especially impact in the local and the regional climate pattern, and that's definitely have a sometimes negative impact on the so-called sustainable energy solutions. For example, biomass, local climate change, and probably this won't be sustainable anymore. And for the hydro cycle as well. And for wind, probably this is for all the wind farms is we build on based on the previous meteorological data, but this could be changed too. So what's your?
Yeah, the example I gave, they are taking regional climate change into effect because they're planning the wood-based system on arid zone plants in the east, so they could tolerate even a further drop in rainfall and it'd still be viable. So there's actually a lot of planning now in Eastern Australia on the fact that climate will continue to dry in that part of the country for the coming decades, including agricultural systems, urban systems, and so on. That's a good point.
Okay, so that may be an example of how we start to connect back to feedbacks from the necessity.
Yeah.
Thanks a lot to Will for this hour and giving us an enormous amount of challenging thoughts, really, really profound issues for the future of our species. Thank you very much.